Welcome to this video, Introduction to Probability. We will start by presenting probability-related terms and definitions with exercises to follow. Please subscribe to the channel and activate the bell button to receive notifications for the new videos. So let's start. So in this video, we will introduce the following concepts: the experiment, the outcome, the sample space, the event, and we will talk about different types of events and their relations to each other, and then how to calculate the probability or the possibility of an event to occur. So let's start. So the experiment is any phenomenon where we expect to see a result. Usually, in the world of probability, we come across such kind of problems. For example, throwing dice. When we throw dice, we expect a number out of 6 numbers to appear. So this is a kind of experiment where we expect to see a result after we do it. Another kind of common problem is pulling a ball from a bag or a box that contains a collection of colored balls. In this case, the boy here is trying to pick a ball from a bag without looking. This ball might be blue, red, or green. In this case, our experiment is pulling a ball from a bag, and the result we see after doing this experiment is either a red ball, green, or blue. The third example is tossing a coin. So when tossing a coin, we expect to see a result that is either heads or tails. So in this case, our experiment is tossing a coin, and the result is either heads or tails. So the outcome is the result that we see after conducting the experiment. For example, in the previous slide, we talked about the experiment of throwing dice. Now, imagine that we indeed threw dice and we saw number 4. In this case, we call number 4 the outcome of the experiment of throwing dice. The next time, of course, we throw the dice, another number might appear. And now let's consider the other example when the boy tried to pull a ball out from a bag that contains blue, red, and green balls. Imagine that the boy indeed pulled a ball and it turned out to be blue. So in this case, our experiment is pulling a ball from a bag that contains blue, red, and green balls, and the outcome is the blue ball, or a blue ball, we can say, because there is more than one blue ball. The third example is tossing coin, and in this example, imagine that we indeed tossed a coin and we got tails. In this case, our outcome is tail. And of course, next time we throw or we toss a coin, the same coin, we might get another result, which is heads, or we might get tails. Now let's move to the other definition. The sample space. The sample space is the set of all possible outcomes of an experiment. So if we considered the previous examples we talked about, Then in the experiment of throwing dice, the sample space contains the numbers from 1 to 6. And in the second example, pulling a ball from a bag that contains colored balls, the sample space is blue ball, red ball, or green ball. There is no other result that we can expect. So the sample space contains all the possible results or outcomes that we might get after doing an experiment. And then tossing a coin, the sample space is the heads and the tails. There is no other possible result we can obtain. Now let's take a simple exercise before we move to define the events of an experiment. In an ice cream shop, 3 kinds of chocolate are sold: chocolate with jam, chocolate with peanut butter, and chocolate with milk. Nadia goes to the shop and picks a bar of chocolate from the box that contains the 3 types of chocolates. Without looking, and she realizes later that it is the chocolate with peanut butter. So, based on that, we want to specify the following. The experiment, in this case, what it is, the sample space, and the outcome. So we start by the experiment. So in our case here, the experiment is Nadia picks a bar of chocolate from the box. This is our experiment. The sample space, and as we defined it before, contains all possible outcomes. So when Nadia picks that piece of chocolate, it might be chocolate with jam, chocolate with peanut butter, and chocolate with milk. So we can say that this is the sample space. And here is the experiment. Now, the third requirement is the outcome. So Nadia picks a bar of chocolate from the box without looking, and she realizes later that it's the chocolate with peanut butter. So the outcome is the chocolate with peanut butter. This is the outcome of the experiment. Now we move to define the event of an experiment. It is any possible outcome or a combination of possible outcomes or a subset of the sample space. Let's take an example to understand this more. For example, when throwing dice, an event could be getting number 2. We call this simple event since it contains only one point in the sample space, and we will see this later as we talk about the types of events. Let's take another example. Event 2, getting an even number when throwing dice. An even number in this case, when throwing dice, means getting either 2, 4, or 6. So all those 3 results satisfy this event because all of them are even numbers. Event 3, getting either red or green ball when pulling a ball randomly without looking from a jar that contains green, red, and blue balls. So this is an example of a combination of possible outcomes. So here, as we know, the outcomes in this experiment might be a red ball, a green ball, or a blue ball. However, an event might be a combination of possible outcomes. So it could be, in this case, either red or green ball. So if we got a red ball as a result of the experiment, or if we get green ball as a result of the experiment, then both of these results satisfy event 3. The probability of an event. So how to calculate the possibility of an event to occur? The probability or the possibility of an event to occur equals the number of outcomes that satisfy the event over the total number of outcomes in the sample space. So we can take a simple example to explain that. If we say that in the experiment of throwing dice, an event E is getting an even number, then the probability of event E to occur equals the number of outcomes that satisfy the event. So the number of outcomes in this case is 3. Why? Because if we got 2 or 4 or 6, since they are all even numbers, it means that we satisfied event E, which is getting an even number. The total number of outcomes in the sample space, so when throwing dice, we might get any number between 1 and 6. So the total number is 6 of the points in the sample space. So the probability of this event E to occur is 3 over 6 or half. And this is logical because when throwing dice, we have 6 numbers that any of them might appear, and the event E that we have is satisfied when either 2 or 4 or 6 appears. So it's half the probability, its probability is half or 50%, in other words. Now, we notice that the probability of an event to occur is always probability less than or equal to 1 and bigger than or equal to 0. So in this case, it's half, okay, between 0 and 1. In other cases, when does it equal 0? It equals 0 when the event that we talk about is impossible to happen. For example, getting number 8 when throwing dice. It's impossible to happen because we don't have originally number 8 on the dice. We have only numbers between 1 and 6. So in this case, the event is impossible to occur, and its probability to occur is 0. And when does the probability of an event equal 1 when it will happen for sure. For example, getting a number between 1 and 6 when throwing dice. Of course, we will get a number 1 and 6 a number between 1 and 6 when we throw dice, because we don't have any other possible outcomes. It would have to be a number between 1 and 6. So the first event we had is getting number 2 when throwing dice. And we want to calculate the probability of this event to occur. So as we said, throwing dice might give us any of the following: 1, 2, 3, 4, 5, 6. Now, there is only one possible way to get number 2. So based on the rule we have just learned, then the probability of event 1 equals the total number of outcomes that satisfy the event, which is only 1, because there is one possible way to obtain number 2, over the total number of points in the sample space, which is 6. So the probability of getting number 2 is 1 over 6. Now, the second event is getting an even number when throwing dice, and we have already done this example. And we found out that the result is 3 over 6, which is half, or in other words, 50%. The last exercise, getting either, the event 3 is getting either red or green ball when pulling a ball randomly from a jar that contains green, red, and blue balls. So first of all, this exercise is incomplete here because we don't know the number of the different type of color in the jar. So we can adjust it and say the number of green balls is 5, the number of red balls is 3, and the number of blue balls is 2. So in this case, the event 3 is getting either red or green ball. It means that the probability of event 3 equal the total number of outcomes that satisfy the event. So it is the number of green balls that we have in the jar plus the number of red balls, which is 5 plus 3, because any of those 8 balls, the 5 green and the 3 red, might satisfy or satisfies the event 3. Now, this 5 plus 3 over the total number of the balls in the jar, which is 5 plus 3 plus 2. So we get from here 8 over 10. We can simplify it further by dividing the denominator and the numerator by 2 to get 4 over 5. And we always, of course, can write it as a percentage, or out of 100. So now we move to discuss the different types of events. We start with the simple event. If the event E has only one point of a sample space, or in other words, only one outcome satisfies the event, it is called a simple event or an elementary event. For example, the event number 2 appearing on the dice is a simple event and is given by E equals the set of 2, the set that includes only 2. Another type of events is the compound event if the event E has more than one point of a sample space, or in other words, more than one outcome satisfy the event. Such an event is called compound event. It's a combination of two or more events. To clarify this further, we take the following example. An event that an even number appearing when throwing dice is a compound event, as there are three possibilities or three outcomes that satisfy this event, which are 2, 4, and 6. So whether we got, after doing the experiment, number 2, or we got 4, or we got 6, we consider in this case that this event happened. Now, the certain event, an event which is sure to occur in any given experiment. And the probability of this type, as we have seen before, is this type of event is 1. An example, certain event, a number between 1 and 6 will appear when throwing dice. So, because as we have seen before, for sure, one number between 1 and 6 will appear when throwing dice. There is no other possibility. That's why this kind of event is always satisfied. We call it a certain event, and its probability is 1, which is 100 out of 100, or 100%. The impossible event, if there is no chance of the event occurring, it is called an impossible event. And the probability of this event, as we have seen before, is 0. For example, number 7 will appear when throwing dice. Since the only possible outcomes are numbers between 1 and 6 as we throw dice, then there is no chance for number 7 to appear. And in this case, we call this event, number 7 will appear when throwing dice, an impossible event, and its probability is 0. The equally likely events. When two events of an experiment are equally likely to happen, they are called equally likely events. For example, when tossing a coin, the possibility of getting heads is the same as the possibility of getting tails. In this case, we call the events of getting heads and getting tails equally likely events, and the possibility of each of them occurring is half, or 50%. The complementary events. For an event E, the non-occurrence of the event is called its complementary event. Complementary events cannot occur at the same time. For example, event E1 is getting an even number when throwing dice. So we can write E1 as the set of 2, 4, and 6. So any of those numbers, if appeared, then we consider that the event E1 has occurred. On the other hand, we have E2 is getting an odd number when throwing dice. So we can express E2 as the set of 1, 3, 5. Similarly, if 1 appeared or 3 or 5, we can say that the event E2 has occurred. As we notice, E1 has a complementary event E2 in this case, and vice versa. We notice that these two events, since they are complementary, they don't have, or they don't occur at the same time. Also, if we combine them together, we can get the sample space. Let's take another example. E1 is pulling a red ball from a box that contains red, blue, and green balls. So E1 is pulling a red ball. On the other hand, E2 is the event of pulling either a green or a blue ball from the box that contains red, blue, and green balls. In this case, we can notice that E1 and E2 cannot happen together. At the same time, E2 is a complementary event of E1, since we can see that combining them together gives us the sample space. So, and in other words, we could say that the non-occurrence of the event E1 is or means the occurrence of the event E2. So if no red ball appeared, then for sure either a green ball or a blue ball appeared. So if event E1 didn't happen, this means that event E2 happened, and vice versa. In this case, we call E1 and E2 complementary events. The last type of events we are going to talk about is the mutually exclusive events. Two events are said to be mutually exclusive events when both cannot occur at the same time. For example, event E1 is getting 2 or 6 when throwing dice. Event E2 is getting 3 when throwing dice. So we notice that those two events cannot occur together, so we call them mutually exclusive events. However, if we said that E2 is getting 2 or 3 when throwing dice, and E2 is getting 3 when throwing dice, then those are not mutually exclusive events, because they can happen together if 3 appears as an outcome. So we do an exercise. Here, Samer pulls one ball from a bag that contains 3 blue balls, 2 red balls, and 5 green balls. Mention a compound event. A compound event could be either a blue ball or a red ball appears. So we notice here that there is more than one outcome that satisfy the event. So we call it compound event, as we have seen before. Mention 2 complementary events. So 2 complementary events could be event E1, a blue ball appears. Event E2, either a green or a red ball appears. We can notice that those two events, first of all, cannot occur together, and second, combining them will give us the certain event, which is either a blue or a green or a red ball appears. Mention two mutually exclusive events. So, for example, event E1, a blue ball appears, and event E2, a red ball appears. So those cannot occur together. However, we notice that combining them not necessarily gives us the sample space, which is either red ball or green or blue, such as in the case of the complementary events. This is a very important point because some people tend to confuse the complementary events with the mutually exclusive events. Mention a certain event, either blue or red or green appears. For sure, one of the three will appear. That's why this event is always satisfied, and we call it a certain event. Mention an impossible event. It could be that an impossible event, an orange ball appears. This is an example. Another example, a blue ball and a green ball appear together. Of course, the last one might happen when we pull twice from the back, but in our examples here, we are considering the pulling to be done only once. The same example, what is the probability of pulling a blue ball? So the probability, or this probability of pulling a blue ball equals the ratio of the number of blue balls, which is 3, to the total number of balls in the bag, which are 3 plus 2 plus 5. In this case, 3/10. What is the probability of not pulling a blue ball? This is a complementary event to the previous one. So the probability, or this probability, will equal 1 or 10/10 minus 3/10, and this will give me 7/10. We can solve it in another way. So this probability will be equal to the probability of pulling either a red or a green ball. And this will be equal to the sum of red and green balls, which is 2 plus 5 over the total sum of the number of balls of different of each color, which will give me 7 over 10, which is the same as this answer. Thank you for watching this video.